Number 1. The Badlands, South Dakota. 242,756 acres of eroded sandstone and mudstone in southwestern South Dakota preserve one of the most catastrophic mammal extinctions of the Cenozoic era. The Lakota named the region Makasika, which translates as land bad. Modern tourists know it for the painted cliffs along Highway 240, the Badlands Loop Road. Between those cliffs lies a kill record 12 million years deep. The event at the base of the Badlands sequence is called the Grande Coupure, French for the Great Cut. 33.9 million years ago, at the boundary between the Eocene and Oligocene epochs, global temperatures fell by 4 to 6 degrees Celsius in under 400,000 years. The Drake Passage opened between South America and Antarctica, isolating the southern continent and triggering the first Antarctic glaciation. The planet cooled, dried, and began the long transition from forested to grassland ecosystems. Mammals caught on the wrong side of the transition did not survive. At least 60% of archaic mammal groups in North America went extinct or were replaced during the Coupure. The Chadron Formation at the base of the Badlands sequence contains the largest bone beds of brontotherese anywhere in the world. Megacerops, the most famous brontothere, stood taller than a modern horse and carried a forked bone horn above its snout. The species is extinct. Higher in the stratigraphy, at a site nicknamed the Big Pig Dig, paleontologists have cataloged over 19,000 specimens of Archaeotherium, a predatory entelodont roughly the size of a cow. The animals died in a shrinking waterhole during a drying phase of the Coupure, and their final positions are preserved in the quarry floor. Dr. Donald Prothero, whose book After the Dinosaurs remains the standard synthesis of Cenozoic mammal turnover, has refined the Coupure timing to within a few 100,000 years. Paul Pearson and colleagues in 2009 used boron isotopes in marine plankton shells to show that atmospheric carbon dioxide dropped from roughly 1,000 parts per million to 500 parts per million across the boundary. Dr. Rachel Benton, chief paleontologist at Badlands National Park, has led excavation of the saber-toothed kill layers where nimravids such as Hoplophonius and Dinictis lie preserved alongside their prey. Mesohippus, the three-toed ancestor of modern horses, appears in bone bed accumulations by the thousand. Three competing theories explain the Coupure trigger. The mainstream view, first argued by James Kennett in 1977, attributes the cooling to the Drake Passage opening and the onset of Antarctic glaciation. A second view, proposed by Bottomley and colleagues in 1997, invokes twin asteroid impacts at Papagai in Siberia and Chesapeake Bay, both dated to around 35 million years ago. A third, advanced by Kumar and colleagues in 2013, points to Ethiopian flood basalts destabilizing the greenhouse gas balance. Each model explains part of the evidence, none accounts for all of it. The Yellow Mounds Paleosol, a band of pale yellow rock visible from the Loop Road, is a buried fossil soil. It is the preserved ground surface of the warmer world that existed before the Coupure, baked into the cliff face. Every half mile of road cuts through another kill horizon. Modern carbon dioxide is rising roughly 100 times faster than it fell during the Coupure, only in the opposite direction. The mammal communities that emerged from that extinction are now being pushed through a second rapid climate shift before the first has fully resolved. And what was reshaping one continent was already reshaping another. Number 2. Cappadocia Türkiye. 350 square kilometers of central Anatolia, centered on the provinces of Nevşehir, Kayseri, and Aksaray, are covered in the eroded volcanic spires known as fairy chimneys. The rock is ignimbrite, the technical term for pyroclastic flow deposits that cooled and welded themselves into tuff. Pyroclastic flows move at more than 200 miles per hour at temperatures of roughly 1,000 degrees Celsius. Any living thing caught in the flow is incinerated in seconds. The ignimbrite sheets that built Cappadocia were erupted between 9.5 and 2.8 million years ago during the late Miocene and early Pliocene from three primary volcanoes. Mount Erciyes, at 3,917 meters, is the largest of the three. Hassan Dağı reaches 3,253 meters. Gulu Dağı is smaller, but produced some of the most voluminous flows. Dr. Gerhard Werner at the University of Göttingen has mapped the 9 major ignimbrite units of the Cappadocia volcanic province, and estimated that the Kizilkaya ignimbrite alone produced 180 cubic kilometers of material. That volume places it in the same size class as the Tambora eruption of 1815, which cooled the entire planet and produced the year without a summer. The Miocene ecosystem vaporized by those eruptions is documented in the nearby Sinap Formation. Ancilotherium, a long-armed Chalicothere, browsed on high branches. Dinotherium, a shovel-tusked proto-elephant, pushed through the understory. Chiralophodon, another early elephant relative, shared the range. The ignimbrites themselves do not preserve whole skeletons. The Salami Monastery tuff, however, contains charred Miocene wood within its matrix, the last vegetation of that lost forest caught mid-burn. Three main theories compete for what drove the volcanism. The mainstream model, proposed by Innocenti and colleagues in 1975, attributes it to subduction of the African plate beneath the Anatolian plate. A refined model by Keskin in 2003 argues for slab detachment, in which a dead piece of subducting crust broke off and allowed hot mantle to rise. A third view, advanced by early Soviet geologists, claimed that the fairy chimneys were Neolithic human carvings. The Soviet model was discredited decades ago and is now considered pseudoscience. Dr. Axel Schmidt at UCLA and Heidelberg has dated single zircon crystals from the ignimbrites, showing that the magma chamber sat crystallizing for up to 500,000 years between eruptions. The fairy chimneys themselves are products of differential erosion. Harder basalt caps protect softer tuff beneath them, and the resulting mushroom shapes erode at roughly 5 centimeters per century. Ahmet Turk of the Turkish Geological Survey has documented over 2,500 individual chimneys within the Göreme National Park UNESCO site. The Byzantine rock-cut churches, carved into the tuff between the 4th and 13th centuries CE, carry frescoes painted directly onto rock that was once a glowing avalanche. One of the most striking traces of human memory of the Cappadocian volcanism is a mural at Tatlahöyük, 300 kilometers to the west. A 9,000-year-old wall painting shows a twin-peaked volcano erupting above a village. In 2014, Ulkakul and colleagues used argon dating to confirm that Hassan Dağ erupted around the time the mural was painted. It may be the oldest surviving landscape painting in human history, and it may be a kill scene. The Derinkuyu underground city, carved into the same tuff, descends 85 meters and could house 20,000 people for extended periods. Neolithic engineering in a landscape built by the kill event that created the tuff. Turkey still sits on the North Anatolian fault zone, and the same tectonic setting continues to drive volcanism and earthquakes today. And if Cappadocia preserves what volcanoes did to mammals, a Scottish island preserves what they did to dinosaurs. Number 3. The Isle of Skye, Scotland. Skye is the second largest island of the Inner Hebrides at 1,656 square kilometers. Its Middle Jurassic rocks, deposited between 170 and 166 million years ago during the Bathonian and Colovian stages, preserve more than 170 individual dinosaur trackways. That is the highest concentration in Britain. The four main trackway localities are Erubanem, Brotharian, which translates as Brothers Point, Duntulm Castle, and Curran and Staffen. The trackways sit in the Duntulm and Kilmaluag formations, laid down in shallow lagoon-all mudflats that periodically dried. Sauropod footprints at Rubanam. Breatharian measure up to 70 centimeters across, wider than a car tire. The prints show herd animals moving in a single panic direction. Dr. Steve Brusati at the University of Edinburgh has led trackway research on Skye since 2015. His 2018 paper in the Scottish Journal of Geology described a dinosaur highway at Brothers Point, a tidal flat crossed repeatedly by large herds. Dr. Neil Clark at the University of Glasgow was the first to formally describe sauropod bones from Skye in the 1990s, when a partial limb fragment hinted at the vast herds the trackways would later confirm. The lagoon that preserved the prints was not empty. In 2015, Brusate and colleagues named Dirkhamheri Shokrasi, a 170 million-year-old marine reptile discovered in the same sequence. The period during which the trackways formed coincided with the earliest rifting of what would later become the North Atlantic Ocean. Volcanic ashfall layers are interbedded with the trackway mudstones, tied to the earliest phases of the British Tertiary volcanic province. The Windsill and the Quilleen magmatic complex on Skye itself are later pulses of the same rifting system. Sulfur dioxide released by these eruptions would have blocked sunlight and collapsed vegetation across regional scales, starving herbivores. The surviving herds recorded their panic as they fled. Three main interpretations compete for the trackway record. The volcanic Ashfall kill model, argued by Broussate in 2018, fits the regional stratigraphy most closely. A drought-concentrated herd model proposed by Clark in 2001 explains the clustered trackways as ephemeral waterhole gatherings during seasonal dry phases. A predator pursuit model published by Wilkinson and colleagues in 2020 reads, overlapping theropod prints as active hunts during periods of ecological stress. Dr. Paige DiPolo, working in Broussate's group, documented a 2020 find of theropod footprints running parallel to sauropod prints. The same direction, the same urgency. Predator pursuit appears in the physical record. Broussate's group used photogrammetric three-dimensional scanning in a 2020 Proceedings of the National Academy of Sciences paper to reconstruct gait speeds of the fleeing dinosaurs. The animals were moving at 6 to 8 kilometers per hour, about the speed of a brisk human jog. In black organic-rich shales between trackway episodes, the Comaluk Formation records anoxic dead zones where the lagoon became chemically hostile to all aerobic life. The panic was not just ashfall, it was also periodic oxygen crashes in the water the dinosaurs drank. The An-Karan site is accessible only at low tide, and tourists routinely walk directly over the footprints without realizing what they are. Skye's annual visitor numbers have tripled since 2015. And while dinosaurs were dying in Scotland, the rift that would one day open the Atlantic was quietly forging the weapon of a kill yet to come. Number 4. The Giant's Causeway, Northern Ireland. The Giant's Causeway is a UNESCO World Heritage Site on the north coast of County Antrim, designated in 1986. It comprises approximately 40,000 interlocking basalt columns, most of them hexagonal, stepping down into the North Atlantic. More than 1 million tourists visit the site every year. According to Irish folklore, the causeway was built by the giant Finn McCool as a bridge to Scotland. The Scottish end survives at Fingal's Cave on the island of Staffa, and it is the same lava flow. The columns formed between 60 and 55 million years ago during the opening of the North Atlantic Ocean. They are the surface of one of the largest large igneous provinces in Earth's history, the North Atlantic Igneous Province, or NAIP. The volumes involved are difficult to absorb. Dr. Henry Patton and Dr. Kerry Gallagher have modeled the total lava output of NAIP at 6 to 10 million cubic kilometers, rivaling the Siberian traps that caused the end Permian extinction and the Deccan traps that contributed to the end Cretaceous extinction. At peak output, the province erupted 40 million cubic kilometers of lava in under 1 million years. Dr. Michael Story at Roskilde University has used argon-argon dating to place the Giant's Causeway main member at approximately 60.5 million years ago. The timing is the significant factor. The NAIP eruptions coincide almost exactly with the Paleocene-Eocene thermal maximum, or PETM, one of the most abrupt climate events in Earth's deep time record. 56 million years ago, global temperatures rose by 5 to 8 degrees Celsius within 20,000 years. The carbon release is estimated at 4,000 to 7,000 gigatons, comparable to the entire modern fossil fuel reservoir. Ocean surface pH dropped by 0.2 to 0.4 units, a level of acidification that dissolves carbonate shells. The signature is a red clay layer found in deep sea cores worldwide, a preserved interval during which calcium carbonate simply stopped forming. Dr. Ellen Thomas at Yale documented the kill toll in the deep sea. 30 to 50% of benthic foraminifera, the single-celled shell builders that dominate abyssal ecosystems, went extinct during the PETM. That is the largest benthic extinction of the entire Cenozoic. Three main theories compete for the PETM trigger. The mainstream view, argued by Henrik Svensson and colleagues in 2004, links direct carbon release from NAIP magmatism to methane hydrate destabilization on the seafloor. A second view, proposed by Lucas Lorenz and colleagues in 2005, invokes orbital forcing by Milankovitch cycles, which warmed the oceans enough to release methane clathrates from the seafloor. A third, more controversial model from Morgan Schaller and colleagues in 2014 suggested a comet impact delivered organic carbon. The Scheller paper drew significant criticism and remains a minority view. The columns themselves form by columnar jointing. As the thick basalt flow cooled, contraction cracks propagated downward from the top surface, and the most efficient tessellation of a cooling sheet is hexagonal. The same geometry appears in mud polygons, in Barnard convection cells, in heated fluids, and in drying paint. Dr. Lee Kump at Penn State has linked sustained volcanic sulfur release to the PETM climate signal, arguing that both fire and brimstone, not just carbon alone, drove the event. Thin tuff layers between the basalt flows at the Causeway preserve evidence of forests attempting to recover during brief pauses, only to be buried again when the next flow came. Before the eruptions, Northern Ireland was subtropical. The Luath Nealch clays, not far inland, preserve palm and cycad fossils from the pre-eruption world. Current human carbon emissions are roughly 10 times faster than the PETM release. The ocean took 150,000 years to buffer the PETM acidification. Ireland holds the weapon, and across the Atlantic, Oregon holds the tombstone. Number 5. Crater Lake, Oregon. Crater Lake is the deepest lake in the United States at 594 meters from surface to floor. It sits in the caldera of Mount Mazama in the Oregon Cascades, a stratovolcano that stood approximately 12,000 feet tall before its climactic eruption. The eruption occurred roughly 7,677 years ago, with an uncertainty of about 150 years, a date anchored by Zdanovich and colleagues in 1999 through Greenland ice core ash correlation. The eruption was classified as a volcanic explosivity index 7 event. It ejected approximately 50 cubic kilometers of magma, 42 times the volume of the Mount St. Helens eruption of 1980. Pyroclastic flows reached 60 kilometers from the vent. Ashfall was documented from Alberta in Canada south into Northern California and east into Montana. Over 900,000 square kilometers of northwestern North America received measurable ashfall. The Mazama ash is now one of the most important tephrochronological markers in the Pacific Northwest, used by geologists to calibrate lake sediment chronologies across the region. Dr. Charles Bacon of the United States Geological Survey produced the definitive mapping of Mazama's magma system in his 1983 Geological Society of America monograph, and his subsequent work remains the standard reference for cascade supereruption modeling. The climactic eruption caused the roof of Mazama's magma chamber to collapse, and the resulting caldera formed in less than 24 hours. An entire mountain disappeared in one day. Klamath oral tradition records the event. The Klamath tribes, ancestors of whom lived in the region at the time of the eruption, call the place Gaiwas, a sacred place. Their story describes a battle between Lau, the chief of Mount Mazami, and Skye, the chief of Mount Shasta, culminating in the destruction of the mountain. Dr. Douglas Durer at Portland State University has worked extensively with Klamath elders to document the tradition, arguing that it represents 7,700 years of eyewitness memory transmitted across generations. Archaeological evidence supports the timeline. At Fort Rock Cave and Paisley Caves in Oregon, sandals, weaving, and tools have been found buried directly beneath the Mazama ash, confirming human presence in the region at the time of the eruption. 3 interpretations compete for the human kill toll. Charles Bacon's 2008 synthesis estimates hundreds killed directly by pyroclastic flows and ashfall, with thousands displaced regionally. Douglas Durer's 2009 work argues for far larger regional population losses, consistent with the scale and specificity of the oral tradition. A more skeptical view, articulated by some archaeologists, treats the oral traditions as composite memories of multiple smaller volcanic events rather than a single 7,700-year-old recollection. That skeptical view is increasingly a minority within the field. Wizard Island, the cinder cone rising from the lake, is not part of the original mountain. It formed between 7,200 and 5,000 years ago as the volcanic system vented residual magma into the newly formed caldera. The lake has no outlet. It is filled entirely by snow and rain, and the water is renewed approximately every 250 years. Secchi disk clarity readings exceed 30 meters, among the highest ever recorded in any lake on Earth. Dr. Manuel Nathanson of the USGS has mapped volcanic mudflows, or lahars, that reached 80 kilometers downstream from the eruption in the Klamath River Valley. The United States Geological Survey currently classifies Crater Lake as a very high-threat volcano. Mazama is dormant, not extinct, and if Mazama's kill radius was continental, a coastline in Mexico records a kill that was planetary. Number 6. Cancún and the Yucatán beaches. Mexico. The Chicxulub impact crater is a buried ring-shaped structure 180 to 200 kilometers in diameter, centered near the town of Chicxulub, Puerto, on the Yucatan Peninsula's north coast just west of Cancún. It formed 66.043 million years ago, a date published by Paul Rene and colleagues in Science in 2013 based on argon dating of impact ejecta. The impactor was a carbonaceous chondrite asteroid, 10 to 15 kilometers in diameter, traveling at 72,000 kilometers per hour according to Collins and colleagues in 2008. The energy released was equivalent to 100 million megatons of TNT, roughly 1 billion Hiroshima bombs. The kill sequence of the first 24 hours has been reconstructed from layered evidence around the world. Within seconds of impact, the fireball ignited forest fires across much of the Western Hemisphere. Ejecta re-entering the atmosphere heated the upper air to roughly 260 degrees Celsius, a phenomenon Robertson and colleagues in 2013 called the broiler effect. Any animal not underground or underwater simply cooked where it stood. Tsunamis were modeled by Range and colleagues in 2022 at heights reaching 1,500 meters at ground zero, though they dissipated rapidly with distance. Some tsunami deposits in Louisiana preserve surge layers over 50 meters thick. The hypercane model proposes that hurricanes with wind speeds exceeding 800 kilometers per hour formed over the superheated crater sea for weeks after the impact. The discovery history of the impact is itself significant. Walter Alvarez, working with his physicist father Luis, identified the iridium anomaly at the Cretaceous-Paleogene boundary in Gubbio, Italy, in 1980. The asteroid hypothesis was contested for a decade. Dr. Alan Hildebrand, using data from the Mexican state oil company Pemex, identified the crater itself in 1991. 75% of all species went extinct at the boundary, including all non-avian dinosaurs, ammonites, mosasaurs, and large portions of marine plankton. The Tanis site in North Dakota, excavated by Robert De Palma in a 2019 paper, records animals killed within hours of the impact by Seichi waves carrying glass spherules from Yucatán 3,000 kilometers away. The Yucatan cenotes, those limestone sinkholes the Maya used for water, ring the crater in a near-perfect arc. They formed because the impact shattered the underlying bedrock, and subsequent groundwater followed the fractures. Tulum, Chichen Itza, and most major Maya sites were located for cenote access. Maya civilization depended centuries later on the hydrology of the kill event. Three main theories compete for the extinction. The mainstream view, established by Alvarez in 1980 and refined by Rennie in 2013, attributes it to the asteroid alone. Gerta Keller and colleagues in 2005 argued that the Deccan Traps eruptions in India contributed significantly, and that the boundary extinction cannot be explained by impact alone. Mark Richards and colleagues in 2015 proposed a combined model in which the impact triggered or accelerated Deccan volcanism, with both factors contributing to the kill. In 2016, Dr. Sean Gulick of the University of Texas led the International Ocean Discovery Program Expedition 364, which drilled the crater's peak ring and revealed that life returned to the crater basin within 30,000 years, faster than expected. The deadly darkness afterward lasted months to years, with soot from global fires collapsing photosynthesis. The Near-Earth Asteroid Monitoring System, SENTRI, at NASA's Jet Propulsion Laboratory tracks every object larger than 140 meters. Current estimates suggest a 1 in 1,800 chance per century of a 1 kilometer plus impact. Small, but civilization threatening. And if Cancun sits over a dead crater, another American landmark sits over a live one. Number 7. Yellowstone National Park, Wyoming. Yellowstone National Park was established in 1872 as the world's first national park. It covers 8,991 square kilometers across 3 states, Wyoming, Montana, and Idaho. The park receives over 4 million visitors per year. Beneath it lies a magma system that has produced 3 super eruptions in its recent geological history, each at or near the top of the Volcanic Explosivity Index scale. The Huckleberry Ridge event 2.1 million years ago was a Volcanic Explosivity Index 8, the highest rating. It ejected 2,500 cubic kilometers of material, over 10 times the volume of Tambora. The Mesa Falls event 1.3 million years ago was a VEI 7. The Lava Creek event 631,000 years ago was another VEI 8. The Lava Creek tuff blanketed most of North America. Ash layers from the event have been mapped as far east as Iowa and Missouri at thicknesses of 2 to 30 centimeters. A repeat eruption today would kill livestock, collapse roofs, ground aviation, and disrupt agriculture across the continent for years. Dr. Bob Smith of the University of Utah has monitored Yellowstone's caldera deformation for decades. The caldera floor inflates and deflates by up to 10 centimeters per year, a slow breathing driven by changes in the magma system below. Seismic imaging by Huang and colleagues in 2015 showed the magma chamber is approximately 10,000 to 14,000 cubic kilometers of partially molten rock with roughly 9% melt fraction. The hotspot track extends southwestward across the Snake River Plain in Idaho. The North American plate has moved 650 kilometers over the stationary plume over the past 16 million years, leaving a chain of older calderas behind it. Dr. Ben Ellis, in a 2012 Nature Geoscience paper, identified 2 smaller eruptions within the Huckleberry Ridge sequence, suggesting the super eruption was actually multiple closely spaced events rather than a single pulse. Half of the world's geysers are in Yellowstone. Old Faithful erupts every 60 to 110 minutes, driven by the same magma system. Grand Prismatic Springs rainbow microbial mats contain thermophile bacteria that live in conditions analogous to early Earth or Mars. In 1959, the Hebgen Lake earthquake, magnitude 7.5, killed 28 people and triggered a massive landslide at the park's northwest edge. 1,500 to 2,000 earthquakes occur at Yellowstone every year, most of them in swarms linked to fluid movement in the hydrothermal system. 3 theories compete on eruption probability. Dr. Jake Lowenstern, former scientist in charge of the Yellowstone Volcano Observatory, argued in 2017 that the next eruption is unlikely within thousands of years because the magmatic state is too crystalline. A popular press narrative insists Yellowstone is overdue based on the spacing of previous eruptions, a framing most geologists reject because 3 events do not constitute a cycle. A third view articulated by Cooper and Kent in 2014 using mineral zoning studies suggests that crystallization may actually release volatiles and accelerate eruption rather than delay it. Dr. Michael Poland is the current scientist in charge of the Yellowstone Volcano Observatory, and his team monitors the park with 30 seismometers and 12 global positioning system stations. Steamboat Geyser entered a phase of frequent eruption in 2018, sending water 130 meters into the air. It is not a precursor to anything, it is a reminder of what sits below. A repeat of Lava Creek would cost $3 trillion in direct damage and drop global temperatures by 10 degrees Celsius for years, causing continental crop failures. And Yellowstone's older super eruption from the Bruno Jarbidge position of the hotspot 12 million years ago sent its ash plume due east and landed eventually in a Nebraska waterhole, preserving a different kind of kill scene. Before that, a Canadian park records what the opposite kind of disaster looks like. Number 8, Dinosaur Provincial Park, Alberta, Canada. Dinosaur Provincial Park in southeastern Alberta was inscribed as a UNESCO World Heritage Site in 1979. The park preserves the Dinosaur Park Formation, deposited between 77.0 and 74.5 million years ago during the late Campanian stage of the late Cretaceous. Alberta was then the coastal floodplain of Laramidia, the western continent that existed when the western interior seaway split North America in 2. The ecosystem was subtropical, warm, and wet, with seasonal monsoon storms generated by the temperature gradient between the epicontinental sea and the interior highlands. Over 58 dinosaur species have been identified in the formation. That is among the highest single formation species diversities in the global fossil record. Dr. Philip Currie at the Royal Tyrrell Museum of Paleontology and Dr. David Eberth have led systematic mapping of the park's bone beds for decades. The park contains over 500 documented bone beds, each one a mass death assemblage. The most famous, known as Bone Bed 30 or the Centrosaurus bone bed, covers 2.3 hectares and contains an estimated 1,000 or more Centrosaurus apertus individuals. That is a ceratopsian herd drowned together. Eberth's 2010 paper in Paleo World applied detailed taphonomic analysis, the study of how bones are preserved after death, and concluded that the herd was swept into a temporary lake basin during a coastal storm surge. The animals drowned on their feet while trying to cross a flooding river. Common species in the park's bone beds include Hypacrosaurus, Lambeosaurus, Corythosaurus, Styracosaurus, Chasmosaurus, and Gorgosaurus. Gorgosaurus was a large tyrannosaurid, a smaller cousin of Tyrannosaurus rex. Gorgosaurus tooth marks appear on roughly 15% of hadrosaur limb bones at the park, evidence that the predators scavenged the drowned herds afterward. Dr. Peter Dodson at the University of Pennsylvania used dinosaur provincial park material for his 1996 book The Horned Dinosaurs, the definitive synthesis on ceratopsian evolution. The Judith River Group, the broader rock package containing the Dinosaur Park Formation, extends south into Montana. The drowning was not a local phenomenon. It operated at continental scale. Dr. Caleb Brown's 2013 paper in Cretaceous Research used the mass death assemblages to demonstrate sexual dimorphism in Centrosaurus, a finding only possible with sample sizes in the hundreds. Three main theories compete for what killed the herds. The mainstream monsoon drowning model formalized by Eberth in 2010 matches the taphonomic evidence most closely. A volcanic ashfall model proposed by Rogers in 1990 for the Egg Mountain site in Montana argues that ash from the Montana volcanic arc periodically killed herds across the region. A third, more speculative view posits that disease pathogens amplified in dense Cretaceous herds, but direct fossil evidence for pathogen presence is minimal. The Dry Island Buffalo Jump site, 200 kilometers north of the main park, preserves a mass death of Albertosaurus, a near relative of Gorgosaurus. 26 individuals died together, another extraordinary mass death assemblage. The park's Badlands landscape continues to form through post-glacial erosion of Cretaceous mudstones. Modern rainstorms expose new bones every year. The modern parallel to the monsoon drownings is direct. Monsoon flooding in Bangladesh, Pakistan, and the Mississippi Delta drowns livestock and people today by the same mechanism that killed Centrosaurus herds 75 million years ago. And if Alberta's bone beds record drowning, Utah's record the opposite kind of death. Number 9. Dinosaur National Monument, Utah and Colorado. Dinosaur National Monument straddles the Utah-Colorado border and covers 850 square kilometers at the junction of the Green and Yampa rivers. The monument was established in 1915 specifically to protect a single sandstone cliff face packed with Jurassic dinosaur bones. The rock unit is the Morrison Formation, a late Jurassic terrestrial deposit between 157 and 150 million years old. The Carnegie Quarry, housed inside the visitor center's Quarry Exhibit Hall, preserves over 1,500 fossil bones still embedded in rock, left as discovered for public viewing. The quarry was found in 1909 by paleontologist Earl Douglas while prospecting for the Carnegie Museum of Natural History. The species list reads like a Jurassic bestiary. Apatosaurus, Diplodocus, Stegosaurus, Allosaurus, Camarasaurus, Dryosaurus, and more than 20 other genera are represented. Dr. Kenneth Carpenter and Ron Tidwell, in a 2005 paper, published the current standard interpretation. The Morrison ecosystem was a subtropical floodplain with severe wet and dry seasonality. During drought years, water holes shrank and animals concentrated around the surviving bodies of water. As the drought deepened, they died of thirst. When the seasonal rains returned, flash floods swept their carcasses into river bars and buried them together. Dr. Ray Kenny at the University of Arizona used oxygen isotopes from fossil fish scales to reconstruct Morrison rainfall patterns. The seasonality he found is comparable to the modern African savanna. Dry seasons lasted long enough that hundreds of square kilometers of lake beds cracked open. Wet seasons were catastrophic. Carpenter's taphonomic studies show that many skeletons at the quarry are partially disarticulated but still in rough anatomical position, consistent with hours to days of surface exposure before burial. Allosaurus teeth have been found embedded in Apatosaurus vertebrae, direct evidence of either predation or scavenging on the drying carcasses. Between 1909 and 1924, more than 800,000 kilograms of fossil material was shipped to the Carnegie Museum. The cast of Diplodocus carnegii, assembled from this quarry's bones, was replicated and sent to major museums worldwide. There are full Diplodocus mounts in London, Paris, Berlin, Moscow, and Vienna, all derived from this single Utah hillside. Professor John Foster of the Utah Fieldhouse of Natural History synthesized Morrison paleontology in his 2007 book Jurassic West. 3 theories compete for how the quarry formed. The mainstream drought-kill floodberry model, refined by Carpenter in 2005, fits the stratigraphy best. A predator catastrophe model proposed by David Gillette in 1994 suggests that theropod pack hunts bogged down in mud and buried themselves along with their prey. A third hypothesis, that linked infections killed entire herds, has been proposed but not supported by fossil evidence. Dr. Dan Chur served as chief paleontologist at the monument for decades and led the description of several new species from the quarry. The Green River Canyon through the monument exposes 1.1 billion years of Earth history in one cross-section. Fremont culture petroglyphs dated between 300 and 1300 CE occupy the same cliffs as the dinosaur bones. The modern parallel to the Morrison kill cycle is live. East African droughts continue to concentrate and kill herd animals at shrinking waterholes today. The Morrison Formation was a Jurassic version of the Serengeti, and a waterhole of a different kind, 12 million years old, preserves the most visceral mass death in American paleontology. Number 10. Ashfall Fossil Beds, State Park, Nebraska. Ashfall Fossil Beds State. Historical Park is in Antelope County, northeastern Nebraska, covering 360 acres. It is a Nebraska State Historical Park and a National Natural Landmark. The kill layer preserved at the site is dated to 11.83 million years ago, a precision anchored by Perkins and colleagues in 1995 through argon-argon dating of the ash itself. The ash came from the Bruneau-Jarbidge supereruption in what is now southwestern Idaho, which at the time was the position of the Yellowstone hotspot. The Bruneau-Jarbidge event was a volcanic explosivity index 8 supereruption, ejecting roughly 1,000 cubic kilometers of material. That is comparable in scale to Yellowstone's own Lava Creek eruption 631,000 years ago. The ash traveled 1,600 kilometers eastward on prevailing westerly winds. At what is now Ashfall, it fell to a thickness of 30 to 60 centimeters. The animals that lived around a large spring-fed waterhole in that part of Miocene Nebraska did not die instantly, they died slowly. Dr. Michael Voorhees, the paleontologist who discovered the site in 1971 while surveying a rain-eroded gully, identified the cause of death as hypersensitivity pneumonitis. The animals inhaled microscopic shards of volcanic glass, which lodged in their lungs and triggered a fatal inflammatory response over days to weeks. The condition is essentially silicosis. The animals drowned in their own lung fluids. The species list shows the Miocene Plains ecosystem in full. Teleoceras major, a short-legged rhinoceros. Pseudohyperion, Protohippus, Pleohippus, and Cormohyperion, 4 genera of small, 3-toed horses. Procamilus, a camel the size of a pony. Saber-toothed deer, multiple species of birds. The stratigraphy of death tells its own story. The lower layer contains the small animals that died first, turtles and small horses. Above them lie the rhinos, which were larger and more resistant to ash inhalation. Families stayed together in the final hours. Mothers lie curled around calves. Calcite mineralization has preserved even delicate hyoids and ear ossicles. Voorhees' 1981 National Geographic feature brought Ashfall to global attention. The Reno Barn Visitor Center opened in 1991, built directly over the active excavation so that visitors can walk above the bones in climate-controlled viewing. 3 main theories compete for the exact kill mechanism. The mainstream ash ingestion pneumonitis model, published by Voorhees in 1981, is supported by the microscopic anatomy of the preserved lungs. A dust storm kill model proposed as a secondary factor suggests that blinding ash drove some animals to trample each other near the waterhole. A third model, advanced by Tucker and colleagues in 2014 using carbon isotope analysis, argues that ash-contaminated water contributed to the kill through ingestion over the weeks before death. Predator skeletons are notably rare at Ashfall. Carnivores, it seems, fled earlier or were less dependent on the central waterhole. The Bruno Jarbidge caldera remains visible in Idaho today, now dormant. The modern parallel is direct and recent. In 1980, the Mount St. Helens eruption killed thousands of livestock in eastern Washington through the same pneumonitis mechanism. Ashfall is the same process at continental scale. 10 places, 10 kill sites. The question left is why humans keep building on them. The answer is not coincidence, it is geology. The landscapes that kill and the landscapes that attract tourists are often the same landscapes for the same physical reasons. Volcanic deposits weather into soft, carvable, erosion-sculpted terrain. Cappadocia's fairy chimneys are visually striking for the same reason they are solidified death. Drought and flood cycles expose bone-rich badlands. The Badlands of South Dakota and the Badlands of Alberta are scenic for the same reason they are kill floors. Impact craters fracture bedrock and create cenote systems. The Yucatán cenotes are the reason Maya civilization flourished, and they exist because of the extinction event that let mammals inherit the earth. Caldera lakes are deep, clear, and beautiful for reasons that kill. The blue of Crater Lake and the violence of Mount Mazama are the same story. Geology has a survivor bias. Modern landscapes reflect the geological processes that formed them, not the ecosystems those processes erased. Tourism economics reinforces the bias. National parks, balloon tours, resort developments, and scenic byways cluster at visually striking locations, and visual strikingness is often produced by catastrophic geological processes. Indigenous naming conventions often remember what modern names forget. Makasixa. Giwas. Names such as National Park flatten violence into recreation. Roughly 25 million people per year, collectively, visit the 10 sites covered in this video. Every paleontologist who has appeared in this video performs essentially the same role. Michael Voreiks at Ashfall, Steve Brusada on Skye, David Eberth in Alberta, Kenneth Carpenter at Dinosaur National Monument, Charles Bacon at Crater Lake, Sean Gulick at Chicxulub, Donald Prothero in the Badlands, Axel Schmidt in Cappadocia, Michael Story at the Giant's Causeway, and Bob Smith at Yellowstone. They are interpreters. They translate evidence of geological violence into language that tourists can absorb on a weekend visit. Museums and national parks mediate the translation, softening it where necessary to remain accessible. 3 of the 10 sites remain geologically active. Yellowstone is monitored by 30 seismometers and 12 global positioning system stations, with the Yellowstone Volcano Observatory providing daily updates. Crater Lake is classified by the United States Geological Survey as a very high-threat volcano. The volcano is dormant, not extinct. The Cappadocia region sits on a still active subduction zone, and the analog at Campi Flegrei in Italy is currently showing unrest. A volcanic event of the magnitude that built Cappadocia is not impossible on a human timescale. The Paleocene-Eocene thermal maximum, the kill event, the Giant's Causeway, records as a weapon, has a direct modern analog in present-day carbon emissions, which are running roughly 10 times faster than the original PETM release. There are also kill sites that have not yet been mapped. Only about 200 impact craters have been identified globally, out of thousands predicted by modeling. The Hiawatha crater, under Greenland's ice, was not confirmed until 2018. Submerged kill sites under the North Sea, Doggerland, and the Sunda Shelf remain only partially explored. Satellite gravity mapping is revealing buried impact structures across the Canadian Shield. Ground-penetrating radar surveys continue to find new bone beds in national parks that have been studied for over a century. Deep-sea cores continue to yield new climate archive data. The Capitanian extinction, a major Permian kill event, was barely recognized before the 1990s. The ratio of known to predicted kill events remains a live area of research, and artificial intelligence pattern recognition is beginning to surface structures in old survey data that human analysts had missed. The relationship between knowledge and action on geological risk is complex. Insurance industries maintain detailed models of volcanic, impact, and tsunami risk, but they price those risks against human economic timescales, not geological ones. Tourism economies grow in places like Cancún despite, or perhaps because of, the dramatic geology. Pompeii has been rebuilt repeatedly since the 79 CE eruption of Vesuvius. Sunk cost and short human memory are not failures of education. They are features of how humans relate to slow onset hazard. Klamath oral tradition preserved direct memory of Mazama for 7,700 years, which is as long as almost any oral tradition on Earth. The Tohoku tsunami stones in Japan, which carry warnings from past events, were ignored by modern residents in the years before 2011. Risk desensitization from familiarity is a near-universal pattern across cultures. The common feature of all 10 sites covered here is that the land encodes the violence, even when human memory does not. The stripes of the Badlands are a document that can be read layer by layer. 33 million years of Cenozoic mammal turnover compressed into a drivable road. The columns of the Giant's Causeway are the preserved structure of planetary violence, each hexagon a fragment of cooling basalt from a province that cooked the oceans. The Pompeian-style preservation at Ashfall is a frozen funeral for 200 Miocene mammals, their last breaths recorded in the silica lining their lungs. A landscape is a text. Paleontologists practice a particular kind of slow listening. They take years to read a single cliff. Indigenous traditions have been doing the same listening on longer timescales. Klamath memory of Mazama, Maya adaptation to Chicxulub cenotes, Anatolian occupation of Cappadocian tuff. These are millennia-long observations that predated scientific confirmation. Deep time empathy is a skill that can be developed. Human lifespan, at roughly 80 years, is shorter than the average interval between Yellowstone supereruptions by a factor of approximately 8,000. Further reading for anyone who wants to go deeper includes Donald Prothero's After the Dinosaurs, Steve Brusati's The Rise and Reign of the Mammals, David Eberth's published work on Cretaceous bone beds, Charles Bacon's monographs on Cascade volcanism, and Walter Alvarez's T-Rex and the Crater of Doom. Visiting responsibly matters. Do not remove fossils. Do not step on trackways. These sites survive because enough people, over enough decades, chose not to pocket them. Every landscape is a record of violence imperfectly held in stone.